root review. So a little vocabulary review first. A factor or divisor is a number that goes into another number without a remainder. To rationalize the denominator, to multiply the numerator and denominator by the same radical expression so that the denominator is then a rational number. And a perfect square is an integer that is the square of another integer. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. So these perfect squares, 1, 4, 9, 16, 25, those are numbers that we're really going to be working with here. So some rules to multiply two radicals together, you just multiply the insides. So radical a, or square root of a times the square root of b, is the same thing as the square root of a times b. And then the square root of a divided by b, you can break that square root up and say the square root of a over the square root of b. And then the square root of a squared, the square root in squaring something, those are opposites of each other. So those end up canceling out and I'm left with just a. So an example here, the square root of 108. I start out with my rule, or my numbers up here, by 149. And I try to find the highest square root that goes into 108. So on my calculator right now, I'm just doing 108 divided by 36, and I get 3. Okay, so then I can break this up and say that that is equal to the square root of 36 times the square root of 3. The square root of 36 is 6, so it's 6 times the square root of 3. So I tend to just go down the list. With that, 108 divided by 4 is 27. So you could have said that this is 4 times 27. However, 27 is not simplified, so we would have had to do that again with 27 because 9, which is a perfect square, goes into 27. So 36 is the highest perfect square that would go into that number, and that's what you're looking for. So here for 32, I'm just taking in my calculator, 32 divided by 4. That gives me 8. But I don't think that's the highest square root, so let's just keep going. 32 divided by 9, decimal. 32 divided by 16, 16 and 2. That's pretty good. So the square root of 16 times the square root of 2. The square root of 16 is 4, so 4 times the square root of 2 there. Number 3, you can only add or subtract square roots when the square root, the number on the inside, is the same. Okay, so we all have square root of 5, square root of 5, square root of 5. Since they are the same number, I can add and subtract the number on the outside. So 6 minus 2 plus 8. 6 minus 2 plus 8 is 12. So my final answer here is going to be 12 square root of 5. Number 4, when I'm looking at those two, the square root is not the same, so I cannot do anything. The square root of 6 does not simplify. So my final answer here is just going to be the same problem. So 5 square root of 6 plus 3 square root of 2. Number 5, 2 times the square root of 45 plus the square root of 8 plus 4 times the square root of 20. We got to simplify all of these first. So I'm going to rewrite this. So 2 times, let's try to break the square root of 45 up. 45 divided by, I always start with 4. 4 is a decimal. 45 divided by the next highest square, or perfect square, is 9. 9 and 5. So 2 times the square root of 9 and the square root of 5 plus the square root of 8 can be broken up into 4 and 2. and then 4 times 4 times 5. 4 times 5 is 20. 4 is a perfect square. So then I'm going to take the square root of all of my perfect squares here. So I get 2 times 3 times the square root of 5 plus 2 times the square root of 2 plus 4 times 2 times the square root of 5, which is 6 square root of 5 plus 2 times 2 plus 8 square root of 5. I notice I have two terms that have square root of 5 on it. So then I can say that this is 6 plus 8 is 14. So 14 square root of 5, and then just add on that 2 square root of 2 there. Number 6, when we're looking at this one, just multiply the numbers on the outside and multiply the numbers on the inside. So 3 times 2 is 6. 3 times 5 is 15. 15 cannot be simplified any further. Number 7, when I'm multiplying this, you can only multiply the number on the outside with the 2. So this is going to be 6 square root of 5. Now, on the opposite for number 8, if I'm multiplying by a square root, I can only multiply my square root by that 6. So 2 times 3 times 6, which is 2 times 18. Can 18 be simplified? Let's check. 18 divided by 4. 18 divided by 9. Yes. So then let's simplify it, because 2 times 9 times 2. 9 is the square root of 9 is 3. So 2 times 3 times the square root of 2. Or 6 times the square root of 2. Number 9, we have to rationalize the denominator because it is not proper to leave a radical in the denominator. So in order to rationalize the denominator, we are multiplying by the denominator on both the numerator and denominator. So here I'm going to take radical 3 over radical 3. Just multiplies those together, so 5 times the square root of 3. The square root of 3 times the square root of 3, that would technically be 3 times 3 is 9, so the square root of 9, and the square root of 9 is 3. Number 10, again, multiply by the denominator, so square root of 2 all over square root of 2. Make sure you're multiplying the inside of our square roots, so 6 times the square root of 20 equals 2. You can divide here on the outside. So if those two numbers are divisible, you can divide them. So 3 times the square root of 20, but the square root of 20 can be broken up. 4 times 5, so 3 times the square root of 4 times the square root of 5. Square root of 4 is 2, so 3 times 2 times the square root of 5, or 6 square root of 5. Notice how I'm taking this step by step, always showing my work with these. 11, I'm going to multiply by the square root of 3 on the numerator and denominator. So 12 times 2 times 3 is 6. So square root of 6 all over 3. Again, 12 is divisible by 3. So 12 divided by 3 is 4. So 4 times the square root of 6. Number 12, this is technically 5 square root of 6 times 5 square root of 6. So here, multiply the numbers on the outside together. So 5 times 5 is 25. Square root of 6 times the square root of 6 is the square root of 36. Square root of 36 is 6. So 25 times 6. 25 times 6 is 150. When we start working with radicals and fractions, you can either simplify the inside of your fraction first or break up your radicals. So I'm going to show you all different ways how to do that here. So here, 25 is not divisible by 9. I would get a decimal, so I'm going to break it up and say the square root of 25 all over the square root of 9. Square root of 25 is 5. Square root of 9 is 3. Done. Number 14, 27 divided by 9 is 3. So 27 divided by 9 is 3. So here is just going to equal the square root of 3. So you can divide on the inside of your radical first. So notice how I'm always checking that. So 9 divided by 27 is 1/3. So let's do the square root of 1/3. We can break that up as well. Square root of 1 all over the square root of 3. Square root of 1 is just 1. So 1 over the square root of 3. You have to rationalize your denominator now, though, because you cannot leave a radical in the denominator. So multiply square root of 3 all over square root of 3, which becomes the square root of 3 all over 3. And that's all.